Preparing for Automation Engineer Interview Questions and Answers Interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What is test automation, and when should a team automate a test? Test automation uses software to execute checks, compare actual and expected results, and report outcomes with minimal human intervention. I automate stable, repetitive, high-risk, or frequently executed scenarios, especially regression and data-driven coverage. I avoid automating one-time exploratory tests or rapidly changing features too early. My decision considers maintenance effort, defect risk, execution frequency, and feedback speed. Automation should improve confidence and delivery efficiency, not simply increase the number of scripts. While answering, define automation clearly, distinguish it from manual testing, discuss repeatability and regression value, and explain selection criteria such as stability, execution frequency, risk, maintenance cost, and return on investment. Question 2. How would you design a maintainable automation framework from scratch? I start with a clear layered design. Test cases express business behavior, page or service objects encapsulate interaction, and utilities handle common concerns. Configuration stays outside code, while test data is versioned and environment aware. I add structured logging, screenshots or traces on failure, reporting, tagging, and parallel execution where safe. The framework runs locally and in C with identical commands. I also document conventions and review early examples before expanding coverage. Make sure to cover layered architecture, separation of tests from implementation details, configuration management, reusable utilities, test data strategy, reporting, logging, parallel execution, dependency management, and continuous integration readiness. Question 3. What is the page object model, and what problems can it create? The page object model encapsulates a page's locators and user actions so tests describe intent rather than selector details. If a login button changes, I update one object instead of many tests. However, giant page objects become difficult to understand and encourage unrelated behavior. I prefer focused page or component objects, returning the next relevant object after navigation. For complex flows, task-based or screenplay patterns may communicate business actions more clearly. In your answer, explain encapsulation of locators and actions, reduced duplication, readable tests, component boundaries, risks of oversized page objects, and when a screen or component object is more appropriate. Question 4. How do you handle flaky automated tests? I first classify the failure as a product defect, automation defect, environment issue, or timing problem. Then I inspect logs, screenshots, traces, network calls, and historical patterns. I replace arbitrary sleeps with condition-based waits, isolate test data, remove shared state, and use stable selectors. Limited retries can reduce infrastructure noise, but never conceal persistent failures. I track flaky test rates, assign ownership, and quarantine only temporarily while fixing the underlying cause. Be sure to mention failure classification, deterministic synchronization, stable test data, isolation, environment analysis, retry limits, observability, quarantine policies, and measuring flakiness rather than hiding genuine defects. Question 5. How would you choose reliable locators for UI automation? I prefer dedicated, stable test identifiers when available, followed by accessible roles, labels, and meaningful attributes. They express intent and survive layout changes better than long XPath chains or CSS paths based on position. I avoid selectors tied to generated classes, indexes, or visual structure. If the application lacks suitable hooks, I discuss adding them with developers. Locator quality is a design concern, so I review it during implementation rather than after failures. Focus on locator stability. semantic accessibility attributes, dedicated test identifiers, CSS versus XPath trade-offs, avoiding positional selectors, component boundaries, and collaboration with developers to create automation-friendly markup. Question 6. What is the difference between implicit, explicit, and fluent waits? An implicit wait applies a general lookup timeout across element searches. An explicit wait polls for a specific condition, such as visibility, clickability, or a state change. A fluent wait is an explicit wait with configurable polling intervals and ignored exceptions. I usually favor explicit or fluent waits because they match the application's behavior and fail faster when appropriate. I avoid mixing implicit and explicit waits, and I treat fixed sleeps as a last resort. Make sure to explain polling behavior, scope, timeout control, ignored exceptions, synchronization risks, and why condition-based explicit waits are generally safer than global implicit waits or fixed sleeps. Question 7. How would you automate an API and validate its response thoroughly? I validate more than the HTTP status. I check authentication behavior, headers, response schema, required fields, data types, business rules, and meaningful error messages. I include positive, boundary, malformed, unauthorized, and conflict scenarios. For chained workflows, I extract identifiers safely and clean up created data. I also verify idempotency where applicable and test response timing against agreed limits. Contract tests can catch breaking changes before consumers discover them. In your answer, cover request construction, authentication, status codes, headers, schema validation, business assertions, negative cases, chained data, idempotency, cleanup, and separating transport checks from business behavior. Question 8. How do you manage test data in an automation framework? I favor test-owned data created through APIs, factories, or builders rather than relying on shared records. Each test receives unique identifiers and cleans up safely, or uses disposable environments when practical. Sensitive data is masked and stored in secure configuration, never committed to source control. For parallel runs, data must be isolated and deterministic. I use database fixtures only when necessary, because direct database dependence can bypass important application behavior. Discuss isolated and repeatable data, factories or builders, environment configuration, masking sensitive information, setup and cleanup, parallel execution, database controls, synthetic data, and avoiding brittle dependencies on shared records. Question 9. How would you integrate automated tests into a CI/CD pipeline? I place fast unit and API checks early, followed by focused UI smoke tests and broader suites in parallel or scheduled stages. The pipeline provisions a known environment, injects secrets securely, publishes reports and traces, and preserves artifacts for failed jobs. Pull requests receive rapid feedback, while nightly or release pipelines run deeper coverage. Quality gates should reflect risk, not a simplistic pass percentage. Reruns are controlled and visible, never used to mask failures. Be sure to mention test layers, pipeline stages, environment provisioning, secrets, parallelization, artifact retention, quality gates, failure visibility, rerun policy, and balancing feedback speed against coverage depth. Question 10. How do you run UI tests in parallel without creating unreliable results? Parallel execution works when tests are independent, data is isolated, and each worker owns its browser or session. I avoid static shared variables, ordering assumptions, and common accounts that can mutate state. The framework must create thread-safe drivers and clean resources in finally blocks. I also match worker count to environment capacity. Excessive concurrency creates false failures. Before enabling parallelism broadly, I compare serial and parallel results and investigate differences systematically. Cover independent test design, isolated data, separate browser contexts, thread-safe drivers, resource limits, ordering avoidance, environment capacity, deterministic cleanup, and diagnosing failures caused by concurrency. Question 11. What is the testing pyramid, and how does it influence automation strategy? The testing pyramid recommends many fast unit tests, fewer service or integration tests, and a small number of end-to-end UI tests. Lower layers provide quick, precise feedback, while UI tests validate valuable journeys but cost more and fail for more reasons. I use the pyramid to place assertions at the lowest meaningful layer, not to eliminate UI coverage. Critical user workflows still need end-to-end checks, but they should not carry every business rule. Explain the cost and feedback differences among unit, service, integration, and UI tests. Discuss appropriate coverage distribution, acknowledge exceptions, and connect the model to faster, more stable pipelines. Question 12. How would you investigate an automation failure that occurs only in C? I compare C and local versions, environment variables, browser settings, time zones, permissions, network routes, and available CPU or memory. I inspect screenshots, video, console logs, traces, server logs, and exact timestamps. Then I reproduce with the same container or command locally if possible. I check whether parallel load changes behavior and whether data differs. The goal is to identify a specific environmental assumption, not simply add retries or longer waits. Focus on comparing environments, browser and dependency versions, timing, resources, network access, configuration, test artifacts, reproducibility, and distinguishing infrastructure failures from genuine application defects. Question 13. How do you apply data-driven and parameterized testing effectively? Parameterized testing lets one test flow validate multiple meaningful inputs. I separate data from logic and choose cases using equivalence partitions, boundaries, valid and invalid formats, permissions, and representative business combinations. Each case gets a descriptive name so failures are actionable. I avoid generating every possible combination when pairwise or risk-based coverage is sufficient. External files or factories help when data is large, but the test still validates its input schema. Mention separating test logic from data, meaningful partitions, boundary values, schema validation, readable case names, external data sources, avoiding combinatorial explosion, and maintaining traceability for failures. Question 14. What is mocking, and when would you use mocks, stubs, or service virtualization? A stub provides predefined responses. A mock can verify interactions, and service virtualization simulates an unavailable or expensive dependency. I use them to test edge cases, failure paths, rate limits, and workflows without relying on unstable external systems. However, mocks can drift from reality, so I pair them with contract and integration tests against real services. I avoid asserting implementation details unless the interaction itself is part of the requirement. In your answer, distinguish mocks, stubs, and virtual services, explain isolation and deterministic failures, discuss contract risks, verify interactions carefully, and identify scenarios requiring real integration environments. Question 15. How would you test an asynchronous workflow or event-driven system? For asynchronous workflows, I assert eventual outcomes within a defined deadline rather than expecting immediate consistency. I capture a correlation ID, poll a reliable state endpoint or consume the relevant event, and log every observed transition. I test duplicates, out-of-order delivery, retries, timeouts, and dead letter behavior where relevant. Arbitrary sleeps make tests slow and flaky. The system should also expose enough observability to connect a failed assertion with the responsible event chain. Cover eventual consistency, correlation identifiers, polling with deadlines, event ordering, duplicate delivery, retries, dead letter handling, observability, ID impotency, and avoiding arbitrary sleeps in asynchronous assertions. Question 16. How do you measure the effectiveness of an automation suite? I measure effectiveness through escaped defects, risk-based coverage, defect detection rate, execution time, failure validity, flakiness, maintenance hours, and feedback latency. Test count alone is misleading because duplicated or weak checks add little confidence. I review which production incidents lacked coverage and whether failures lead to useful diagnosis. A strong suite detects important regressions quickly and reliably while remaining affordable to maintain. These metrics guide investment and remove low-value tests. Be sure to discuss defect detection, escaped defects, execution time, stability, meaningful coverage, maintenance effort, feedback speed, false positives, and business risk rather than relying only on test counts. Question 17. How would you handle CAPTCHA, OTP, email, or other external dependencies in automation? I do not attempt to defeat production security controls with brittle techniques. In a controlled test environment, I use approved test hooks, fixed OTP providers, seeded accounts, or a mail and messaging sandbox. When possible, I verify delivery through an API or test inbox rather than screen scraping. I retain a small number of realistic integration checks with the real dependency. All bypasses are environment restricted, audited, and documented so they cannot weaken production security. Discuss test environment bypasses, controlled test hooks, API-level verification, secure fixtures, inbox or message APIs, avoiding production workarounds, and preserving realistic coverage through targeted integration tests. Question 18. How do you test authentication, authorization, and security-sensitive workflows? I test valid and invalid authentication, lockouts, session expiration, refresh behavior, logout invalidation, and token misuse. For authorization, I verify every role can perform permitted actions and is denied restricted ones, including direct API access and object-level manipulation. Secrets remain in secure stores, and tests never print tokens. I also validate audit events where required. Security testing complements, rather than replaces, dedicated penetration testing and threat modeling. Focus on role-based access, authentication methods, session lifecycle, token expiry, privilege escalation, negative authorization checks, secret handling, audit events, and collaboration with security specialists. Question 19. Describe a time you improved an automation suite or reduced execution time. On one project, the regression suite took nearly 4 hours and frequently blocked releases. I analyzed duration and failure history, moved repeated business rule checks to API tests, removed redundant UI cases, isolated data creation, and safely parallelized independent groups. Runtime fell to about 50 minutes, while critical journey coverage remained intact. We tracked escaped defects for several releases and added ownership for flaky tests. The lesson was to optimize feedback based on risk, not simply delete slow tests. Structure the response with situation, diagnosis, intervention, measurable result, and lessons learned. Include parallelization, test removal, lower layer coverage, data optimization, and safeguards against reduced confidence. Question 20. How do you collaborate with developers and product teams to improve quality through automation? I involve developers and product partners before implementation by reviewing acceptance criteria, risks, API contracts, and testability needs. During development, we agree on stable interfaces and useful diagnostics, then review automation code alongside product code. Failures are triaged collaboratively using evidence rather than blame. I report coverage gaps, defect trends, and delivery risks in business language. Automation is most effective when quality is shared across the team instead of delegated to one function. Mention shift-left practices, shared acceptance criteria, testability discussions, code reviews, risk-based planning, defect triage, contract ownership, documentation, and communicating automation outcomes in business terms. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.